Okay, good morning, guys. I hope you are doing your revision good. So this is Yadavalli Vishishta, and today we're going to discuss about Psm formulas and how to tackle them. So let's not waste our time and move on to the first question. In a district, the following data were recorded in 2023. Stillbirths were 500, live births were 5,000 from the government maternity hospital. Among them, infant deaths were 150 due to multiple causes, and you're in survey for community medicine. What is the infant mortality rate? So they're asking for infant mortality rate. And always remember, guys, here since I have time, I read the question from the top, but I recommend you to read the question from the last. See what they're asking first, and you will know what they're asking, and according to that, you can sort out your information which was given in the question. So they're asking for infant mortality rate. Since they're asking for infant mortality rate, by now you should have known what's the formula for infant mortality rate. Total number of deaths from 0 to 1 year by total number of live births per thousand. Okay, this 1,000 value is constant for all the pediatric formulas. If they're asking for infant mortality rate or neonatal mortality rate or prenatal mortality rate, for anything, this 1,000 is constant. So don't press up if they didn't give for if they're asking for 1,000 or 100. Okay, just know it's for 1,000. So total number of deaths from 0 to 1 year. They are already given here. Infant deaths less than 1 year is 150. So here 150. In question they might give you to confuse you like stillbirths and live births and separate things. Always remember, no matter what they give you, if the child age is 0 to 1 year, that comes under infant. Okay, so don't add stillbirths or live births here. In the formula we know that we need to calculate for live births, so only live births. Don't add your stillbirths count. Only 5,000 into 1,000. So the answer is 30. But in case if you don't remember the formula, and you can also use this method. I think many of us already know, and I have already told you in the previous video of the last session. In the question, they were asking for 5,000. There were 150 infant death, right? So for 1,000, how much? You just need to cross multiply. X is equals to 150 into 1,000 by 5,000. You'll still get the answer. But always remember, always prioritize yourself to remember this formula rather than doing this backdoor step. I know this is very easy, but still, always try to remember the formula because they might not always ask you to calculate this. They might also ask you to what is the formula which we'll be using for infant mortality rate or neonatal mortality rate, whatever it is. But just in case, if you don't remember the formula, and you can also use this method, but you need to understand the question. You need to understand the question, only you can do this. Okay, let's move on for the next question. A population of 20,000, 40 existing cases of hypertension on the 1st January 2024. During the year, 20 new cases were detected. 1,000 patients died and 100 migrated out. What is the point prevalence at the end of the year per 1,000 population? So they're asking for point prevalence at the end of the year. So, formula for point prevalence is number of cases at the end of the year by population at the end of the year per 1,000. So number of cases at the end of the year. First, on the starting of the year itself, we already have 400 existing cases of hypertension. So 400. And during the year, we got 200 more new cases. So 200, but 100 were died, minus 100, and 100 migrated out. So total will be 400, right? This will be our numerator. And the population at the end of the year. For this, they already told that they were at the starting of the year, we have 20,000 population, but 100 died and 100 migrated out. So we need to minus 200 from 20,000. So out of 20,000, 100 died, 100 migrated out. So total will be 19,800. So our denominator will be 19,800 by per thousand. So you can use the calculator which will be given on your screen. I think it will be listed on the right upper corner, I guess. I don't know if they have changed it, but you will be provided with a calculator, digital calculator. So no worries, you can use that. Don't waste your time unnecessarily. So answer will be 20.2. So next question. Here they're asking what is the last line? What is the sensitivity of the test? So they're asking for sensitivity. What do you mean by sensitivity? Sensitivity means we are calculating for actual deceased cases. Actual deceased cases. So let's read the question. In a cervical cancer screening program conducted in a community, the results of the screening test were compared with gold standard diagnosis. In the screening test for cervical cancer, true positive were 180. Let's note it down. True positive were 180. False negative were 20. And false positive were 50. And true negative were 750. These are the values which were given in the question. So let's write down the formula for sensitivity. True positive by true positive plus false negative. So we need to know what we are calculating the actual diseased cases. So true positive by true positive plus false negative. 180, true positive value is 180 by 180 plus, what is the false negative value? 20. 180 by 200. And here's the catch. In the options they are given in the percentages, right? So in the percentages means we need to get the answer in the percentage. So we multiply it with 100 to get the answer in the percentage. So don't get confused. I just wrote it for your clearance, okay? For your understanding. 90. So the answer is 90. Let's move on with the next question. Let's read the last line. What is the total dependency ratio of this community? They're asking for dependency ratio. Okay. Let's read the question. In a population of 10,000, the number of individuals aged 0 to 14 years is 3,000. Those aged 15 to 64 years are 6,000. Okay. And those aged 65 years and above are 1,000. Based on the above data and considering the standard definition used in population studies, what is the total dependency ratio of this community? So, before writing the formula, let's note down what they have given. 0 to 14 years were 3,000. 15 to 64 years were 6,000. 65 years and above were 1,000. So formula for dependency ratio of this dependency ratio non-working population by working population. Okay, this is the formula, but you need to know which age group is does come under the non-population working non-working population and working population. So 0 to 14 obviously they don't work, so they don't come under working population. They go under non-working population. And again, 65 years and 65 years above, these age group also goes under non-working population. So here 3000 plus 1000 by, so the only working population is 15 to 64 age group. So 6000, 4000 by 6000. So if you do the math and if you just, you will get the answer 0.6. Use a calculator, guys, don't waste your time. Let's move on with the next question. They're asking for relative risk. Okay. So it's a cohort study. A cohort study was conducted to assess the association between a smoking exposure and the development of a disease, pulmonary fibrosis. In a cohort study, what is the relative risk? They're asking for relative risk. Okay. So they already given exposed and unexposed two groups. Okay. So first, to understand this, let's just revise our cohort study. So what is a cohort study? How it's done? Cohort study. I'll tell you an example. Let's take this example, which were given in the question first. First, I'll let's say I've taken a healthy group of people since this is 200 and this is 200. Let's say I have took 400 healthy people. Okay, and I divided them into two groups. 200, 200, and let's say this is a this group. One group will be exposed with risk factor. Let's say they are exposed with smoking. Okay, as given in the question, they are exposed with smoking. And these 200 group, they're not exposed to any kind of risk factor. Okay, they're not exposed to smoking. Since we are taking smoking as a risk factor, they're not exposed to smoking. Okay, so I'll tell these 200 people to smoke and these 200 people to not to smoke. And I'll observe them for 10 years. I'll observe this both the groups for 10 years. After 10 years, I will see who has developed pulmonary fibrosis or any kind of carcinoma or anything. Since they have given in the question pulmonary fibrosis, let's think it's pulmonary fibrosis. And I will see how many members have this developed this disease. So according to the question, exposed means exposed with risk factor. This smoking. This group is not exposed. Okay. So exposed with risk factor, they develop 60 people. 60 subjects would develop with the disease and 140 were not developed. And here 30 developed. I'll keep the plus symbol so you know. 170 did not. Okay. According to this question. So by now I hope you understood the concept of cohort study. So here they're asking for relative risk. Relative risk. Let's write down the formula for relative risk. Incidence exposed by instance non-exposed. Okay. So instance exposed in the sense, what do you mean by instance exposed? Here in the formula, we are seeing how many deceased people were exposed with the risk factor. This means how many deceased people were exposed with the risk factor. So 60. 60 by instance non-exposed. So how many people, even though not they were not smoking, but still they got pulmonary fibrosis? They are 30. 30. And you know the answer, it's 2. So answer is B. I hope you are understanding my explanation. Let's move on with the next question. So let's read the last line. Calculate the positive predictive value. Okay. A dengue diagnostic test was conducted to detect dengue disease in among Sri Lanka population. Among the tested individuals, using the data below, true positive were 90, false positive were 30. Okay. So they're asking for positive prevalence value. Let's write down the positive prevalence value formula. True positive by true positive plus false positive. Here, true positive predictive value is we only concentrate on the positives. No matter it's true or false, we only concentrate with the positives. So the formula will be with the positives itself. So true positive value is 90, false positive is 30. And again here, if you have noticed, in the options, all the options were given in the percentages. So we will multiply it with 100. 90 by 120 into 100. If you do the calculations, you will get the answer 75%. Okay. So answer is C. So this is an easy question, guys. Let's move on with the next question. Okay, what are they asking? What is the specificity of the test? So what do you mean by specificity in the first place? Specificity means true negative, true negativity. So we'll be concentrating on the mostly on a true negative and false positive. Positive is nothing but as it's a negative, but it's falsely we have gotten it as positive. So we're concentrating on the only on the negatives. Let's first decode this. Write down the values. First, let's read the question. Out of a total 2,000 patients assessed for HIV, 200 were confirmed positive. And new ELISA screening tests were conducted on the same group, identifying 200 positive cases, but only 130 of them actually had the disease. What is the specificity of this test? Okay. So first, what according to the question, true positives means they already told you, but only 130 of them actually have the disease. So these people are true positive, comes under true positive cases. Okay. So that is true positive. And true negative, truly negative. So they identified 260 positive cases, but out of 2,000, we have 260 positive cases. Okay, according to ELISA screening test. But the rest of them all were given a negative. So they were truly negative. So we'll just minus 2,000 minus 260 and we'll have the value of 1,740. Okay, so true negative value is 1,740. Next, false positive. So in the 260 cases, only 130 of them were actually having the disease. So rest of the 130 were falsely positive. So those people will come under false positive. 260 minus 130. Okay. I hope you're understanding this. So specificity formula. Oh my gosh. Formula for specificity is true negative by false positive plus true negative. So we are only concentrating on the negative. Okay, true negative value is 1,740 by false positive is 130 plus 1,740. So in the options they were given in the percentage. So again, we'll multiply it with 100. 1740 by get 1870 into 100. So again, you can use the calculator and you will get the answer as 93%. I think it will be 93 point so. It's 93%, option C. Okay. Okay, let's move on with the eighth question. Let's read the last line. What is the odds ratio for the association between the exposure and the disease? So let's read the question first. A case control study was conducted to investigate the association between exposure to a certain risk factor and development of a disease. The following data were collected. Based on the above data, what is the odds ratio for the association between the exposure and the disease? So they're asking for odds ratio here. So let's write down the odds ratio formula first. Number of cases exposed into multiplied number of control non-exposed by number of cases not exposed into number of controls exposed. This is the formula. You need to memorize this formula, guys. So just to understand, let's rewind what is the case control study. Okay. Since they didn't give any specific risk factor or any disease, let's take an example. So, let's say since they are given for total 200, okay. Let's say I've taken two groups. One group is 200 people, and this is a case group, and the control group is also with the 200 people. Okay. So what is a case group and what is a control group? Case group means people who are already with the disease, let's say lung cancer. Okay. These people, these 200 people, they already have lung cancer, and this control group, they are healthy people. Okay. They don't have lung cancer. They're healthy group. So let's say healthy. And this case group is with lung cancer. So in this study, what I will do is I'll go back to 10 years. Means in this past 10 years, I'll go and check how many people have exposed with the risk factor. So our risk factor, let's say it's smoking. Okay. And let's say according to this question, exposed with risk factor smoking, case is with the disease, lung cancer. These people know. Okay. So according to this question, in this 200 people in the case group, there were 120 exposed and with the disease. So 120 people were smoking from the past 10 years or whatever it is. But usually we take it for 10 years. Okay. 10 years they have been smoking, and 80 people were not smoking. Okay. So in this control group from the 10 years, these people were only 80 people were not sorry, it's 60. Sorry, my bad. 60 people working, but they don't have disease. And 140 people were not smoking. Okay. So this is the case control study. We take a particular population, we divide into, particular population, it should be a case group and a control group. Case group will be presented with the disease, and the control group will be the healthy population. and we go back in time and we'll see if they were exposed to any particular risk factor so that they got this disease. So odds ratio is we are correlating with the exposure of risk factor and with the disease. So we want to know, does the risk factor play any role in causing this disease? So that's what we are doing right now. We'll see if there are any relation. So no, so according to the formula, number of cases exposed and number of controls non-exposed. Number of cases exposed are 120 into number of controls non-exposed controls, but not exposed 140 by number of cases not exposed 80 into number of controls exposed 60. So you can just if you can use a calculator, don't waste your time. You'll get the answer 3.5. Okay, option is B. So according to this, we will know that we can also say that there's 3 times more higher risk for getting a lung cancer in a person who is smoking. Okay, you can also get that's what we are doing this formula and this calculation for. We need to know the relation between the risk factor and the disease. So let's move on with the next question. They're asking for under 5 mortality rate. Okay, if I ever. Let's read the question first. In a district health survey conducted over 1 year, the following data were recorded. A district in Telangana with live births of 10,000 and infant deaths 300 with pneumonia. Deaths between 1 to 4 years is 100 due to improper nutritional causes. So what is the under 5 mortality rate? Okay, let's write down the formula first. Number of deaths from 0 to 5 years by number of live births per 1,000. I told you this is the standard number, 1,000. So number of deaths from 0 to 5 years. So we need the value for this. Infant death rates 300. Infant means 0 to 1 year old, right? So 300 and deaths between 1 to 4 years. So they're also under 5. So plus 100. That's it. And for the denominator number of live births, we take 10,000 as given into 1,000. So don't get confused here. We are taking total of 400. I just cancelled right away. So you will get the answer 40. Option is C. Okay. For this kind of questions I told you, if you don't remember the question, you can also use your brain and use your childhood mathematics knowledge. You can always cross multiply with the question if you can understand this question properly. So they're telling for 10,000, we have 400 deaths. So for 1,000, how much? We'll take it as x. X is equals to, because multiply this 400 into 1,000 by 10,000. We'll get the answer 40. Okay. If in this method you can use if you're running out of time, or if you don't remember the formula, you can also use it. So okay, but as I told you before, please try to remember the formula. We never know what I don't know. We never know what kind of questions they might ask you. Not every time they're going to ask you a simple question, right? So the last question. During the calendar year 2024, a municipality reported 1,250 live births. The mid-year population of the same municipality was 50,000. Ignoring migration and assuming uniform population distribution, what will be the crude birth rate? So they're asking for crude birth rate. Let's write down the formula for crude birth rate. Number of live births by total mid-year population into 1000. Okay, mid-year means when do you consider it as mid-year? We consider July 1st as mid-year. Okay. Until then, we need a population until July 1st. So number of live births given in the question is 1,250. 1,250. So I already gave you mid-year population, which is 50,000. 50,000 into 1,000. So I think we'll get the value of 25. So as we calculated for 1,000, they already gave you 1,000. And you should also see in the option, we are calculating for mid-year population. So these both options. And we got the value of 25. So this is the answer. Answer C. So that's it, guys. I think you can also use the cross multiplication for this also. Let's see. For 50,000, we have the value of 1,250. Right? For 1,000, how much? You can also do this. I'm sorry. You get the same answer, 25. So answer will be 25. So as I told you, always prefer your formulas. So that's it, guys. That's it for this session. I hope you understand a little at least. So you might be thinking that they were all the easy questions, but trust me, guys, I want to ask you if in case they're asking you for calculations and all this stuff, they'll be asking you very easy questions. You don't have to force yourself to learn the very complicated questions. That's not our standards yet. So don't waste your time on this. I think they'll only ask for 2 or 3 questions. Further, you don't need to go beyond your time zone and everything. So focus on what is needed and don't try to read any new topics right now because we are running out of time. Always try to revise what you learned. It's okay. Even if you are leaving a huge ton of syllabus behind, it's fine. Just read what you have learned and answer the questions with a very clear mind. Don't overthink your answers. There will be very simple questions, guys. Don't overthink and make this complicated. Okay. I hope you do well in your exam. See you next time. Bye.